Hello and welcome to INE's CCI Service Provider version 5 learning path. Today in this course we will talk about BGP attributes, specifically MED. Now MED is not a well-known attribute. It is an optional attribute and it is non-transitive, which means that I can send it across an eBGP neighbor, but that neighbor would only have MED set within its AS. It would not go across multiple ASs. So MED is non-transitive. You can set MED inbound from a neighbor, or you could set MED outbound to an eBGP neighbor. But it does not go across all the ASs. If I send you a MED, you would see the MED only within your AS. So now MED is a bit tricky because sometimes if you don't have the right parameters set, then MED may not work. Let's look at those conditions why MED would not work and what do you need to do to make it work. To demonstrate MED, I would use this topology where I have three routers, router 1, 2, and 3. They all are in AS1. Router 4 is in AS2, router 5 is in AS3, and router 6 is in AS4. My BGP neighborship has been pre-configured between all these routers. So 1 and 2 are BGP neighbors, 2 and 4 are BGP neighbors, 4 and 5 are BGP neighbors, 5 and 6 are BGP neighbors, 3 and 6 are BGP neighbors, and 1 and 3 are BGP neighbors. 2 and 3 are not forming BGP neighborship. All the routers are iOS XZ routers except for R3, which is an iOS XR. Now, internally within AS1, I have pre-configured OSPF also. So there is OSPF running internally, so R2 and R3 can reach each other through OSPF internally. Besides that, R1 has also been pre-configured as a route reflector so that he can give the routes learned from R2 to R3 and whatever routes he learns from R3 to R2. So let's look at how MED can work. As long as your previous attributes are the same, which is your weight, local preference, AS path, origin, if all of them are the same, only then MED would be considered for path selection. MED, again, lower is better, default is 0. So let's look at from this route's perspective, which is 5.5.5.5. Now R5 is advertising this route in BGP, and this route is being advertised using a network statement, which means that R5 is going to set the origin code as I. Now looking at this diagram based on the BGP neighborship without me making any changes to my path selection, how do you think traffic is going to flow by default? R2 should be going to 4, R3 should be going to 6, and R1 should be going to 2. This should be by default. Why is that? Why does R2 choose R4 and not R1? Think about it. Think from perspective of attributes. Have I configured weight? No. Have I configured local preference? Again, no. I have not set the AS path. So if I look at from R2's perspective, how many hops is R5's loopback? If he goes from R4, it's 2 hops. If R2 goes through R1, how many hops would R5's loopback be? Again, 2 hops. It's a hop of AS, not hop of routers. So AS path is the same. Origin, we haven't changed. It is right now I from both the neighbors. So it reaches MED. Right now we haven't configured MED, so default MED is 0, which means R2 would select R4 based on eBGP preferred over iBGP. Similarly, R3 would prefer R6 because eBGP preferred over iBGP. As far as R1 is concerned, R1 would prefer R2 because of router ID. All the previous attributes are the same, so R1 would select R2 based on router ID. Lower router ID is preferred. Now, to demonstrate MED, what we would do is I would go to my XR3 router and configure inbound when I receive R5's loopback from R6, I would change the MED to 1. Default is 0. So I'm increasing the MED so that R3 would see a higher MED from R6 now, and automatically R3 should choose R1 as the next hop to reach R5's loopback. So my traffic should automatically start going from here. Let's verify if that works. So before I start any configuration, let's quickly verify what we said earlier, that R2 should be going through R4 by default. So if I look at my BGP table, show IP BGP, you can see that R2, to get to 5555, it is going to R4 directly. If I look at XR3, show BGP IPv4 unicast, show BGP IPv4 unicast, XR3 is also going through R6, which is eBGP preferred over iBGP. If I look at router 1 and do a show IP BGP, you would see that R1 is going through R2 because of lower router ID. So this is by default. Let's go and change the MED value. So let's go to XR3, create a prefix set to match that route. So I could do it without a prefix set also, but let's create one. Let's name this R5 loopback 0. And give it as 5.5.5.5/32. End set, and let's create a route policy from R6. And my condition would be if destination includes the prefix set which was R5 loopback 0, then I should set the MED to maybe 1, else pass. Let's do an endif and end policy. So I basically created a policy which matches the prefix set, basically matches the route. If the route matches, change the MED value from 0 to 1 and then put it in the BGP table. Remaining routes should not be affected. I will now call this route policy in my BGP. Let's do a commit. So go back here, commit, and let's do a show run router BGP. So as of right now, I do have a route policy attached inbound coming from R6. I will change this to use my new route policy instead of the pass. So router BGP 1, I have my neighbor, route policy from R6 inbound, and let's try and do a commit. And let's look at my show run router BGP 1. So now I have this from R6 applied inbound from that neighbor. So when I receive a route from R6, I would check for the route policy from R6, which basically has the condition that if the prefix set which contains 5555 matches, I would change the MED to a higher value. The effect of this, if I look at my BGP table, show BGP IPv4 unicast, you should see that I have a higher value learned from R6, so I have a MED of 1. And the route learned from R1, which is through R2, the iBGP was basically 0 because I never changed the MED there. But why am I still using the eBGP and not using iBGP? Because eBGP is preferred over iBGP, right? But then that comes after MED. Only if MED is same, it then compares the next criteria, which is eBGP over iBGP. But I have changed the MED. I have changed the MED to a higher value. So it should have taken the iBGP route, not the eBGP route. The reason it is not working is because look at the neighbor AS, okay? Look at these two routes. I have learned these two routes, the same route, 5555. I have learned the same route from two neighbors. One is R1, one is R6, correct? But look at the AS path. Obviously, the hops of AS has to be the same. Otherwise, MED would never be the deciding factor. If the hops are different, then AS path would be the deciding factor. The hops has to be the same. However, if you look at the neighbor AS, when he goes through R1 and exits R2, what's my neighbor AS? Neighbor AS is AS2. But if I go directly to R6, my neighbor AS is 4. Now, if your neighbor AS is different, what's going to happen? MED would not be considered. It would skip MED and go all the way ahead to the next criteria, which is eBGP preferred over iBGP. So even though I had set the MED, it did not do anything. It skipped MED because the neighbor AS value was different. Basically, MED can only be compared if the neighbor AS is the same. Obviously, the hops also has to be the same, but the neighbor AS has to be the same, only then MED can be compared. So to actually explain this in a better way, let's pull up a Cisco document which basically has this, exactly the same thing that we are doing, given as an example. Let's go and pull one document out. So to see that document, you can go to google.com. Let me bring this right here. So go to google.com and search for deterministic MED. The first link that you see here, let's read that document. Now there are two commands in BGP which is by default disabled. The first command is BGP deterministic MED and the second is BGP always compare MED. Both these commands are disabled by default. Now what happens when this is basically disabled? Let's see that. Now look at this example here. I have a router which has learned the same prefix, which is 10.0.0.0/8. I have learned this specific route from 3 neighbors: neighbor 1, neighbor 2, and neighbor 3. So I have received the same route from, let's assume I have 3 neighbors, and I have received the same prefix from 3 neighbors. So I have entry number 1, entry number 2, and entry number 3. Entry number 1 is the newest neighbor, and entry number 3 is the oldest neighbor. Okay? So whichever is the oldest neighbor goes at the bottom in the BGP table. If I look at my BGP table right now and look at this, I have these 2 routes, right? 20.6.19.6 is at the bottom, which basically means that R6 must have been my oldest neighbor. So this is entry number 1, this is entry number 2. Newest neighbor always goes on top in the BGP table and the oldest neighbor goes at the bottom. Now, when both these commands, which is BGP deterministic MED and BGP always compare MED, when both these commands are basically disabled, what's going to happen? He will always compare entry number 1 first with entry number 2. So it goes top down. He will compare entry 1 with entry 2. Now look at this example here. When both the commands are disabled, okay? Entry 1 would be compared with entry number 2. Here, the hops of AS is the same. They both are 1 hop away. However, the neighbor AS is 500. Here, the neighbor AS is 100. Since the neighbor AS is different, MED cannot be compared. Even though entry number 1 has a lower MED and entry number 2 has a higher MED, but MED cannot be compared because the neighbor AS is different. Since MED cannot be compared, it goes to the next criteria, which is eBGP over iBGP. They both are eBGP neighbors. So that's the same. It then goes to router ID. Router ID of entry number 2 is lower than entry number 1. So entry number 2 is the winner among the 2. Now entry number 2 is compared with the next entry, which is entry number 3. Again here, the neighbor AS is different, so MED cannot be compared. Even though the MED here is lower and MED on entry number 2 is higher, MED cannot be compared. Then it compares the next criteria. eBGP is preferred over iBGP. Here entry 2 has eBGP, entry 3 has iBGP. So entry number 2 is the winner, and that goes in the routing table, which you can see here. Entry 2 is chosen as the best path because of external eBGP over iBGP. Now let's compare this in our table. I have these two entries, right? All my previous attributes are the same. My weight, local preference, it's not locally originated, AS path, origin, they all are the same. MED, here is lower, here is higher. But because the neighbor AS is different, 2 versus 4, MED cannot be compared. It goes to the next criteria. This is an eBGP neighbor, this is an iBGP update. So eBGP is preferred over iBGP. That's why this route was chosen as the best path and MED was not compared. Going back to the same document, now what happens when I turn on the command BGP always compare MED? I still keep BGP deterministic MED turned off. I still keep that off. But I turn on BGP always compare MED. When you turn on always compare MED, MED will always be compared irrespective of your neighbor AS being different. Even if your neighbor AS is different, MED will be compared. So here, what's the change? Look at this entry again. So again, entry 1 would be compared with entry 2. Entry 1 is the newest neighbor, entry 3 is the oldest neighbor. So entry 1 would be compared with entry number 2, and here, because I have always compare MED turned on, entry 1 MED can be compared. Entry 1 has a lower MED, so entry 1 wins this time, not entry 2. And now entry 1 would be compared with entry number 3. Here again, MED can be compared because I have always compare MED, and because entry number 3 has a lower MED, and entry number 3 goes in the routing table, which you can see here. Entry 3 was chosen as the best path. Now let's look at the next example, example number 3. This time I turn on BGP deterministic MED, but I turn off always compare MED. Again, I have 3 entries. Now what BGP deterministic MED does is that instead of placing the routes in the BGP table based on newest to oldest, instead of doing that, what it does is if you turn on BGP deterministic MED, it groups similar neighbor ASs in one group. So it doesn't matter in which order my neighborship was formed. It does not matter. What it would do is whichever neighbor ASs are similar, they would put them in one group. So if you look here, even if entry 1 came first and entry 3 came last, normally without deterministic MED, if entry 3 came last, then it would be at number 1 because newest is on top. But now what's going to happen, if you see here, entry 2 and entry 3, they both have the same neighbor AS, right? So these two routers or these two entries are put in one group. Let's say group number 2. And all the dissimilar neighbor ASs are put in the second group, which is, let's say, group number 1. So this is group number 1, this is group number 2, entry 2 and 3. Now within group 1, he will compare top down. So in group 1, I only have one entry, which means in group 1, the winner of group 1 is entry number 1. Within group 2, there are 2 entries, so he will compare that top down. Here, because the neighbor AS is same, it can compare MED even if your always compare MED is disabled. It can compare MED within group 2. Here I have entry number 2 which has a lower MED. So entry number 2 is the winner of group 2. So entry 1 was the winner of group 1, entry 2 is the winner of group 2, and now both the winners would be compared with each other. So entry 1 and entry 2 would be compared with each other. Here, because I have always compare MED disabled, MED cannot be compared even though entry 2 has a lower MED. It cannot be compared. It skips that and goes to the next criteria, which is eBGP preferred over iBGP. So entry 1 goes in the routing table, which you can see here. Now what happens when I turn both the commands on, which is BGP deterministic MED and BGP always compare MED? If I turn both of them on, what's going to happen? Here again, winner of group 1, because of deterministic MED, it groups similar people in group 1 and dissimilar in maybe group 2. So here, winner of group 1 is only one person because he's the only person who's different. So he's the winner of group 1. Within group 2, MED can be compared. So entry number 2 is the winner of group 2. Now winner of group 1 and winner of group 2, they are compared. But because I have always compare MED also, MED can be compared. Even if I have dissimilar neighbor ASs, MED can be compared. So this time MED wins and entry number 2 goes in the routing table. So you see how MED can be different whether you have neighbor AS or you don't have neighbor AS. What I would suggest in the lab exam, when they ask you to do some path manipulation and maybe use MED as a path attribute, always look at the neighbor AS. If the neighbor AS is different, go and give the command BGP always compare MED. You should give that command. You don't really need BGP deterministic MED, but always compare MED is something that you would need. So let's go and do this on our router. So go back to router BGP 1. And if I look at here, BGP, I should have the always compare MED here, or maybe it's inside the address family IPv4, unicast, and let's see, we have the BGP. All right, so let's go to our router and configure BGP always compare MED. Now the command for defining BGP always compare MED is different on an iOS XZ and iOS XR. If you look at an iOS XZ, the command is router BGP 1, and here I would say BGP always compare MED. This is the command for iOS XZ. But if you are doing the same command on XR routers, the command is going to be different. So let's go back to router BGP 1 and say BGP best path MED always. So this tells the router that you must compare the MED even if the neighbor AS is different. Let's do a commit and look back at my BGP table. If he prefers iBGP now, which he is, as you can see now, my iBGP route became the best path because now I am comparing the MED, and MED would always be compared even if my neighbor AS is same or even if my neighbor AS was different. So just remember that the command is basically different on an iOS XR versus an iOS XZ. The command is different, but they both mean the same thing. iOS XZ command was BGP always compare MED, and the command inside iOS XR was BGP best path MED always. So now my traffic is flowing from XR3 to iBGP, which is R1, and exiting R2 to R4 to R5. So I'm no more preferring the eBGP. Instead, I'm using the MED value that I set, because I set a MED value coming in from R6. When I receive the route, I increase the MED. Again, remember, your route policies and route map, they must always be in direction of control plane. So I was receiving the update from R6, so I applied the route policy inbound from R6. When I receive from R6, change the MED to 1, which basically means that when XR3 puts the route in his BGP table, he sees a higher MED from R6, a lower MED from R1, and because I have always compare MED turned on, he will compare the MED, and lower MED wins. I hope this video was informative to you, and thank you for viewing.